Okay, let's take a quick look at the sine graph. You see here in blue, I've got the equation y equals sine of x. Some things to notice about it: it goes up to a maximum value of 1 and a minimum value of -1. And it takes 360 degrees to complete one full cycle. And what I mean by that is that every 360 degrees, this graph will repeat itself. So if I zoom out here, we see it starts at 0, goes up to 1, hits 0, goes down to -1, and then hits 0 again at 360 degrees. And it's just going to keep doing that forever and ever, both directions, horizontally left and right. Okay, so one full cycle, the distance it takes for the graph to repeat itself once, is 360 degrees in this basic graph. Okay, so let's take a look at the function and the coefficients within the function. Here is a more general equation for the sine graph: y equals a sine b x minus c plus d. Let's look at what each of these variables are doing to our graph. We'll start with some basics that we would have probably already seen in other topics with transformations. This d here, this we're going to call our principal axis. And that is the line that's going to cut the graph in half. And we know that when we have an equation, say f of x, and we have a plus 5 at the end, so maybe we had an equation that was f of x plus 5, where we just attach a plus 5 at the end of the graph. Well, we know this would shift the graph up 5 units. The same principle holds true here. If we have plus d at the end, it's going to take our graph and shift it up or down in that many units. So this will be our principal axis. That's the line that cuts the graph in half. C, just like in the other transformations we've seen before, C will affect your horizontal shift. This will be your horizontal shift. And like before, C is always kind of the opposite since it's in the bracket. So if we have, say, x minus 5 in the bracket, it's actually going to push it to the right 5 units. And if we have x plus 5 in the bracket, it's going to actually push it to the left 5 units. Okay, we'll look at some more examples later. B affects what's called the period or the cycle. And the way this works is that the period, again, that's just another word for cycle, period is equal to 360 degrees divided by b. So this b isn't the period of the graph, but it affects the period of the graph. Okay, we'll see how that works. And last variable we have here is a. This is our amplitude. The amplitude is the distance from the middle line to the max value, which is the same as the distance from the middle line to the minimum value. And again, that middle line is this principal axis. So the distance from D to the max value will be A. Okay, let's see how this works in this example underneath. We've got y equals 4 sine of 2x minus 30 plus 1, and that's in red. So I've graphed that in red. What's in blue here is y equals sine of x, the basic graph, just so you can see the transformations happening. Okay, so the easiest one to start off with, I think, is out here, the plus 1. That's our D. That pushes our graph up 1 unit, and this becomes our principal axis. So again, that's the line that cuts the graph in half. So if I look just at the red graph and I see what would cut this line in half if I were to draw a line in horizontally, it would be right here at 1. See, if I draw this line here, we see that that cuts my graph evenly, top to bottom, in half. Okay, so that's what the plus 1 is doing. It's creating this principal axis here of at y equals 1. Okay, then we've got this minus 30 in the brackets. So what that's doing is actually pushing the graph to the right 30 degrees. So if it was starting at 0 before, we can see this is the starting point of y equals sine x. It's now starting 30 degrees to the right, so right here. Okay, and we can verify that's true because the original graph starts at 0 and then goes up to its max and down to its minimum and back to 0 again. And we can see at 30 degrees, it starts at what was 0, the principal axis, is now 1. So it starts at 1, goes up to its max, goes back down again, and then hits 1 again. So we verified that this would be our starting point of the graph, and that's because it shifted right 30 degrees. Okay, next we got this 2 here, and again this will affect the period, how long it takes for the graph to repeat itself, but is not the period itself. So we go back to the formula which said, okay, period equals 360 degrees over 2, which is our b value. So 360 divided by 2 is 180. So that means this red graph will repeat itself every 180 degrees. Well, let's verify that that's true. So I start here at 30, so I should, 180 degrees later, I should be back at the same point. So I go 30, go up to the max, down to the min, back to the principal axis at 210. So that's a difference of 180 degrees, right? And we could do that again if I had zoomed out further. We would end up again here at 180 degrees later, so at 390 degrees would be the next cycle. Okay, last thing we have here is 4. That is our amplitude. And again, that's the distance from the principal axis, this dotted line I've got here, to the max value, or the distance from the principal axis to the minimum value. And those will both be the same. So going from the principal axis to the max, how far is that? Well, that goes from 1 to 5, and that's a difference of 4. So we can see that fits there, and just verify that it checks out with going to the minimum. Anywhere on the principal axis to the minimum value, we can see we are at y equals 1. We go down to y equals -3. That's a distance, again, of 4 units. So that's how the amplitude works there. All right, so let's see how that looks and what we would expect based upon this function. We've got y equals 2 sine of 3x plus 45 minus 3. First, let's just identify what's happening. So we got this -3. That's going to shift the graph down 3 units. And that also means our principal axis is at y equals -3. Okay, we've got this plus 45 in the brackets here. That means we're going to shift the graph to the left 45 degrees. The 3 will affect the period. So to figure that out, I'm going to say the period is 360 degrees divided by 3 to give me 120 degrees. That means this graph will repeat itself every 120 degrees. And 2, this is our amplitude. So that means we'll be going 2 above the principal axis and 2 below the principal axis. So we can go ahead and see, well, if our principal axis is at -3, what's the range going to be using the amplitude? Well, I know I have to go 2 below my principal axis. So 2 below -3 is -5. So I'm going to go from -5 to, and then 2 above -3 is -1. So the range of this graph will be from -5 to -1. Max value at -1, minimum value at -5. So I've got all these things happening. And let's go ahead and take a look at what that graph looks like here in Desmos. That would be this graph right here. So I click that, turn it on, see, okay, is everything happening that we thought it would? Well, first of all, -3 should be our principal axis. We can look down here and see -3 cuts the graph in half horizontally, so that works. Plus 45 means we shifted left 45 units, so the starting point here at 0 should now be at -45 degrees. So I'll shift over to the left a bit and see, does that hold true? So -45 would be halfway here, so right there would be our starting point. And verify that's a reasonable starting point. Remember, it needs to start at 0, go up to its maximum, down to its minimum, and then back again. And that's exactly what it does. At 45 degrees, starts at its principal axis, goes to the max, down to the min, and back to the principal. Okay, the 3, we said that affected the period, therefore our period was 120 degrees. So verify that this graph repeats itself every 120 degrees. If we say start at the principal point here, -3, on the y scale, that's -45. So negative 45 plus 120, we've got to do some serious math here. We would end up at 75 degrees, and that would work out, right? So negative 45 to 175. Oh, what did I say? No, just 75. Sorry. Negative 45 to 75 degrees. That would be that difference of 120 degrees. So we can see that's the case, going from principal, max, min, principal. So that's one cycle at 120 degrees. And finding the amplitude of 2 means we go down to negative 5. So we can see our minimum is there. And based again upon negative 3, we go up to negative 1, which is right there.